Okay, everyone, so today we're going to do applications, and I'm going to take this one application at a time, and then I'm also going to try to show you the calculator keystrokes to solve like the last part of it. So all we are is doing a real world phenomenon. Basically, you've got word problems application. And I highly suggest that you try to write or draw out the picture of what's happening here. So you got to read this, and it says, suppose the water wheel with a radius of 7. So I'm hoping that you guys see that this number here is 7. And the figure rotates 6 revolutions per minute. This is going to give us some information in just a minute. You start your watch. 2 seconds later, it's at the greatest height. This is going to be something that we're going to use. The height of y, point P above the surface of the water varies sinusoidally with the number of seconds t that your stopwatch reads. So sketch the sinusoidal. Okay, so here is what I'm going to do. The first thing I see is where the center of my circle is. And this line here is going to represent time. And when this line is at 0, we're starting. And then we're going to continue from there. So let's get in a couple of other lines. So I'm putting this line here. That's the top of the graph. And here would be the bottom of the graph. But then I'm also going to put in here, oops, not a very straight line. Here is where it hits the water line. So you guys see the red is the water line. I should have made it blue, but oh well. Okay, so now to try to understand what's happening. This is the line that I'm going to say is my start line. So when we start, t equals 0. So this point here, oops, has a time value of 0. That means, technically, do you see how I got this? This is where I start. Okay, so then it comes up here and it says 2 seconds later, it's at the greatest height. Now notice, this wheel is spinning counterclockwise, but as time goes on, so if this is time 0, here's time 1, here's time equals 2, it says it's hitting its greatest height, so my wave comes up here and hits this top point. And automatically, you guys better know that this is the point 2, comma, and we'll figure out what else because it happened at 2 seconds. So it hits the top, it's here. So now it's going to go down, and after a certain amount of time, it's going to hit the green line again when we're here. And then as it goes down, it hits the water line right here. And then it hits the bottom. Then it comes, now we're coming back up, so it's going to hit the blue line or the red line again. We continue to come up. It hits the center. And as we would come up, it would hit the top, and it would continue to go on and on and on. Now, we've got to read some numbers and get some things in my picture. The first thing, between the center line and the water, this is 6 feet. Okay, so everybody sees this 6 came from the picture. We also know the radius is 7. So at the very top, so here's kind of where 0 is. This is 6 feet above. So up here, can you see how I got 13? I'm going to change to the yellow. This would be the radius 7. This would be 6. And then there's a 1 down here, but that doesn't help me for that point there. So as I read through these pictures, it said, sketch a sinusoidal. Did that. Now I've already started to work out some of these things. Determine and label the height of y of the center axis. So how high up is this green line? Well, look at here. If this water line, that's the top, that would be flat with the surface, comes up, my D value would be 6. So this is my center line, and my center line is going to equal 6. So what do I know? D equals 6. So it's kind of finding some of the things we did yesterday. So then it says determine and label the maximum and the minimum heights. Well, I happen to already know, because we already talked about it, the maximum is 13. Notice from the red line up is positive 6. From the green line up is 7. 6 and 7 make 13. What is this lowest point here? What's the minimum value, or the smallest that it goes? Well, if we know this whole radius is 7 and this is 6, can you see that I don't know what time this happens at, but this would have a height of -1. So my minimum would be -1. Now, amplitude. Amplitude is just how high, how low this wheel goes. My amplitude is 7, and this would be considered the start of my wave, because I don't start anything here, so the top of it. So I know that it would be positive. It says label the time associated with the first critical point, the maximum or the minimum or center line where both coordinates t and y are known. And when we do that, that's not going to be a D value. Notice I colored that out. That is going to be a C value. Where did it start? Well, if it starts at the point 213, guess what? My C value is 2. Okay, so choose the appropriate sinusoidal. You better know that it's a cosine wave. And now it asks us to determine the length of time it takes for one revolution of the wheel. Now, we got to come up here. We know that 6 revolutions it makes in 1 minute. Okay, so now let's make this easy. 6 revolutions is going to equal 60 seconds. So that means 1 revolution in 10 seconds. And 1 revolution is the same as 1 period. So guess what? This tells me my period is 10 seconds. Now, I need that B value. So the B value is going to equal 2 pi divided by the period of 10, or pi over 2 is the B value. Okay, so write the equation of the sinusoidal. Y equals, amplitude is 7. It's a cosine wave. And its B value is pi over 2. And you can write theta, subtract 2, and then plus 6. Now, I'm going to make a little side note here. Theta, same as little t. So if you wanted to tell me that this is time instead of theta, this would be the general equation, but this specific equation that we made, that theta and that t would be the same. So now that I've got this equation, now we're going to do something with it. Predict the height when you start. So I am going to just plug this in, and I'm going to get y equals 7 cosine of pi over 2 times, oh, my t or my theta is 0 minus 2 plus 6. And I'm going to grab my calculator to do this. And for your calculator, big and red, must be in radians. Pi over 2 is a radian value. So make sure your calculator's in radians. Just punch that in and you should turn out to get 8.16 feet. Now, you're going to do the same thing with number 2. I want you to check it out on your calculator. You should get 13.0 feet. And when you plug in 70 seconds, you should get 8.16 feet. Okay, so now I want you to go, and I'm going to try to make a video on the calculator part on how to do letter D for this one. So turn this one off and check to see if you have calculator video 1 for question 1 part D.